Hello, everybody. So today I'd like to talk to you a little bit about Ecto. So let's start by explaining what Ecto is. Ecto is an Elixir project that you can use to interface with the databases. It's a general project that handles multiple databases, and I'll talk a little bit about how it does it. It has over now it's over 200 contributors and 3,000 commits. It's one of the biggest open source Elixir projects. Yeah, this is Hex, Elixir's package manager site. Elixir has over now also, it's a little bit old here, but it's over 800,000 downloads. I checked Active Record, and the current version only has 1.5 million, but yeah, we're getting there. So yes, this is Abandoning Model and Embracing Data, a gentle introduction to Acto. And I am Michał Muskała. I look like that on the internet. I have a blog when I write something, sometimes. Didn't happen in a long time. And you can find me on Twitter as Michał Muskała, because I'm not very good at naming things. I work with great people at WooMedia, a Copenhagen-based company. And if you're interested in a remote and async team, we're looking for good people. I am also a student at Silesian University of Technology. I had an exam this morning. So why am I even talking to you about that? About Acto and Elixir? So I got to Elixir through Google Summer of Code, which is a program for students where Google pays students to work on open source projects. So I joined Acto and I contributed to Acto. My project was called NoSQL Adapters for Acto. And as a result of this project, there is a MongoDB adapter that is used. And I also think there are a couple of people using it in production. And as a result of the project, I also became a core team member of Acto itself. So after the introductions, let's start with an experiment. Can you raise your hand? Yeah, you can raise your hands. So it should be much easier answering the following questions. So who from you used Elixir? Quite a lot of people. And Acto? Okay, great. And who has Ruby background? And so that's the majority, I think. And something else like C# or .NET. Yeah, there's also something else. It's like Java or something else? Python, okay. Okay, great. So Acto comes from multiple things. One of the big inspirations from Acto's query syntax is LINQ from C#. Another is Active Record, although the recent changes in Acto separated from the Active Record inheritance. There are also some other projects that influenced Elixir, that influenced Acto, like Mobius, the other database library in Elixir, and some Ruby projects like ROM or Trailblazer. So I talked a little bit about that Acto supports multiple databases, and that is because it's built on the idea of adapters. So the adapter for each database handles the translation of the Acto query syntax to the actual SQL, or in case of Mongo, the Mongo query. So there are adapters for databases. There are also adapters for connection pools, because there are several ways you can handle connection pooling. And in the recent changes to Acto, there is this DB connection library created that abstracts all the generic database operations. like handling connections and pooling and transactions. So Ecto itself consists mainly from those four things. It's schema, query, repo, and change sets. And I will talk about them, each of them in more detail. So Ecto schema is the basic module. It's used to define the data structures in your application. There is some macro magic, but underneath it generates a simple Elixir struct. And it also adds some type information on top of that. So Acto is able to properly load data from the database and dump it back, or cast data coming from outside sources, like HTTP requests or stuff like that. There are also supports for associations, like belongs to, has many to many, and basically everything you can expect. So to sum up, you have to declare all the fields you're going to use from your tables and from your data sources. And that prevents you from doing select star, which is very wasteful and you can load a lot of additional data that you don't actually use. And this declaration of schema that you use in your application allows you to get away from that issue. Also, it allows you to declare custom types. It's very easy. In this slide, you see the Ecto date is a custom type provided by Ecto. That is a date. But you can do much more. For example, have a permalink that is saved in a database as just an ID. And when you display it to the user, it's ID plus some slugified title and things like that. And you can handle this at the level of the types. As I said, it's a thin wrapper around Elixir structs. Above that, it also adds some functions to your module for handling integration with other parts of Acto. And what is very important is that schema defines the data you're going to use. It says nothing about the behavior of your data or of your application. So the other part is query. And here the C# people will feel right at home. Because it's, as I said, it's inspired by LINQ. It's very expressive, and this is one of the versions, because there are actually two syntaxes, and I will show both of them. With simple queries, you can simply use like Elixir terms. So you say you simply say where WPRCP is less than 0 or is nil. But if you need to handle something more difficult that is not supported out of the box, you can inject arbitrary SQL into your queries. So for example, here we have the Postgres full text search. And it's very easy to extend that. Ecto queries are also, here's another example of use of fragments with MongoDB, where you can inject like arbitrary MongoDB query parts. So here's the geo search. You can also abstract Ecto queries to functions and compose them easily. So here we have a function that creates some filtering. So it takes some query from the filter, sanitizes it, builds the search, preloads the location. I will talk about preload in a second, and orders it by some things. As you can see, it's quite expressive, quite easy to understand. And you can also extend queries easily. As I said, you can use fragments to do that, but you can use macros to write those fragments for you. And it's, I think, a great pattern where you don't necessarily have to remember what is the SQL function to do that. You can create your macro that's named reasonably, and use it in the queries directly. And here's an example from our application. So as you can see, it's doing some geosearch in Postgres. It does couple joins and then uses the macro we defined earlier to use the actual PostgreSQL function. So yeah, Ecto also integrates very easily with various extensions from PostgreSQL. So for example, the geosearch or the TS query, I think, like the full text search. There's also support for subqueries. So you can create a query and then use it as a subquery in another one. So it's very, very easy to compose your queries, to build them up from smaller parts. So as we saw, Ecto queries has two syntaxes, the keyword one, the from, and the pipeline one with the Elixir pipeline operator. As I said, there is this idea of preloading. So there is no lazy loading in Ecto. So basically, if you don't do something crazy like loading stuff in your view, you will never experience n+1 queries, which is very, very nice. But you have to, in your queries, preload everything you will need later on. It's easily extensible, as I said, with fragments and macros. And the syntax you saw, it's compiled into data structures, and it's not actually translated to the SQL until it reaches the database adapter, and then it's translated into proper SQL for each database, because it differs. And it's composable. So, okay, so for now we have only data structures, yes? Schemas define structs and data. Queries are compiled with the fancy syntax, are ultimately compiled to data. So where does the stuff happens? We have the data, we need to add behavior. And that's where repo comes in. Repo is an interface to the database. Everything that happens in your application that touches the database goes through repo. So we can be sure that if there is no repo in a place, there will be nothing happening to the database. It's completely separated by the single interface. There is also some macro magic to generate the modules, but it defines ultimately a simple Elixir gen server that you put in your supervision tree and start it as part of your Elixir application. And here's a big difference between Acto and, for example, Active Record and Rails, because there you build your application in Rails. With Acto, and you build an Elixir application using Acto. It's a subtle difference, but it matters when you have a bigger application and multiple things that could interfere with each other. And here they don't, because the thing that manages everything is Elixir and not any particular library. So to sum it up, as I said, repo isolates or impure operations. And by impure, I mean the operations that have side effects that we don't like in functional programming, but that we have to use to actually do stuff. Because it's great to have pure functions, but we have to actually do something. An application that does nothing is not really interesting. Is an interface to the database, and outside of the repo, everything is plain data. And I think here we're going to look at change set. That is, I think, one of the most interesting ideas in Acto. So change set is, again, a data structure to encode changes in your data, in your schemas. So, for example, you have a request that comes with some params, and you loaded a schema from the database, and you want to update it. So what do you do? Well, first, you need to cast the params to the proper types. Yes? So the cast call here will look at the schema declaration we saw before, here, and we'll see that the wdate is date, so it will try to parse date format, and the temperature is integer, so it will parse integers, and the PRCP is float, it will parse floats, there are timestamps, and they can be other fields as well. So here your types control this, how the data is converted into Elixir from the outside world. Because when your request comes in, from example, from HTTP, everything is strings, and you have to convert it to something more understandable and more usable inside the application. And as you can see, we pass the params that are allowed, and this is a simple list of the fields that we allow to change in this particular change set. So you are sure that the request won't change some other fields. And this is really important from the security standpoint. Then we apply some validations. We have the built-in validate required function, and we pass it the list of the required parameters. And then we have some custom validate params function that do some validations underneath. And this is the great thing about change set, is that all of this is just functions, and functions are very easy to compose, very easy to extract, and very easy to test. So it makes a great change from like module level DSL or class level DSL that is global, that is and that is really hard to extend. Later we also handle associations. So this for the people coming from Rails, it's something similar to accepts nested attributes for, but it does not save anything because there is no repo involved, so it can't do that because it doesn't know where to send the data. But it will create nested change sets for each of the associations and create this recursive data structure, then that when you pass it to the repo, everything will be executed. So this is like a delayed execution of the things you want to change in your data. We also have this idea of embeds, and I will talk about it also. And then we have some standard validations like length validation, format, or inclusion in some list. Again, we have some custom functions to validate email. And ultimately, we have the unique constraint. And this is also an interesting idea. How do you validate uniqueness? So what is the standard way? You do a query to the database, check if there is such an email, and then you try to save it. But as we know with concurrent applications, then can be something else happening at the same time that already saved the email between the time we checked for it and we actually saved it. So the only place that knows if something is unique is the database. And databases already have the mechanism for handling unique constraints via indexes. So let's say we will handle unique constraint on the email field, and if that constraint fails, we will generate a proper error message in the application layer. So at this point, we don't do any queries to the database. We just save in our change set that if there is an error or if there is a unique violation on the email field, we should generate an error on the email field here. Yes? So we don't do any additional queries, and we rely on the database to do this. And unique constraint is just one of the examples. There are constraints for foreign keys or for exclusion constraints. Basically, every constraints you can create in Postgres. You can handle them in Ecto. So the embeds, this is something that comes from my work on Mongo, because in Mongo you generally, instead of having like associations between collections or tables, you save everything in a document that is nested inside. But when implementing that, we realized that you can do actually something similar in Postgres or other databases using JSON and the JSON-B column type. So what embeds are in Postgres, in Mongo they are saved as nested fields in your document. In Postgres, they will be saved in a JSON column, serialized and properly saved, and then loaded again. And it's a very convenient way to handle this, because you give your JSON a structure. You use the same schema that you used for the regular tables. You can use them for embeds and have all the typecasting, all the validations, and everything. And this is very convenient when you handle this. And I think we saw the uses of this far exceeded what we expected when we implemented that. So to sum it up, change sets encode data as the changes you want to do to your data as a data structure. No validations are global. When you, for example, have different validations for create operations and different for update operations, you can just create multiple change set functions that create different change set for create or update. And you can extract the common stuff to a function that you will call. So it's just functions, and it's very easy to compose, very easy to change, because you can pass another change set into those functions as well. That's, as I said, multiple change set functions for different circumstances, and it's easily extensible with just functions. And as a final idea, something that is new and introduced to the Acto 2.0 that is not yet released, but is in the RC, is this idea of Ecto multi. And this is an idea to encode a transaction as one thing and have it contained also in a data structure again. Those functional programmers are boring, always data structures. So here the two functions on the top create change sets. As we saw before, they can do various validations and stuff and whatever you want. And then we create a multi, and we say we want to update the account with that change set. We want to insert some log that something was changed. And this is password reset, so we want to remove all the sessions for the user. And what will be returned from this function is the structure multi that encodes all those changes, but nothing is executed yet. So, well, for example, when you want to test it, you don't have to execute it. You can just introspect into the structure and see if everything is set correctly, that everything does what you want it to do without executing it. And when you want to execute it, we load the account. So I don't know if from those of you who had experience with Elixir, if you saw the with syntax, but it basically says if the thing matches, if the pattern matches on the particular line, go forward. If it doesn't, return whatever was returned and does not match the pattern. So it's very easy to, it's used to handle nested case statements. Because without it, we would have like, if the load accounts returned okay, so we continue. Otherwise, we return the error. And then if the repo returned okay, we continue. Otherwise, we handle the error. And it becomes very repetitive and fits well with applications and with doing stuff in multiple steps where each of the steps can fail. So as we can see, after we loaded the account, we create the multi with the functions we saw earlier and pass it to the repo.transaction. At this point, as I said, when we pass something to the repo, it's executed. So it will do the transaction, change all the data you wanted it to change, and if everything will succeed, it will return you the results. If something will fail, the transaction will be rolled back, and you will get back the thing that caused the error and all the changes so far that were made up to the point that the error happened. And finally, we send some notifications to the outside service, and that is also an example of how to do like after commit callbacks, something similar to that, because Ecto does not have callbacks in your schemas. So because it's just data, and callbacks are behavior. So you basically build a function that wraps the transaction, and that does the thing you want to do after the transaction. And you call this function instead of calling repo directly in your controllers or whatever. And finally, we return the account from this operation. So multi encodes a transaction as a data structure. You can think of it somewhat, if you understood the idea of change sets, multi is something like change set is to your schemas exactly the same like multi is to a single change set. So it allows you to build the set of operations you want to perform on a more higher level. Instead of saying change this field to that, you want to say do this whole change to those tables and that change there in a single transaction. And as I said, you can test your transactions without actually touching the database, which also has a huge benefit in terms of performance of your tests. So, but those things we saw up to now are not very far from things like Rails. Well, you define your active model, active record class. Yeah, you have this repo stuff, but it's not really different. So what is different is that you can use all of that, or you can choose the parts of Ecto you want to use. And for example, if you want to just use queries and you don't want to use schemas, you are very welcome to do so. But instead of we saw before there was like from W in weather, which was the module name. So we can query the table users where we don't have the schema. So for example, below you have to say, you have to tell Acto that start at is a date time because it can't know that. But other than that, you can use all the features of Acto without actually using, just picking the features you want to use. So it does not enforce anything on you and does not lock you in with that you have to use all the features or nothing. You can pick and choose what you like. And I didn't said it earlier, but with queries you can do all the things that you can do in regular SQL. So group bys, having, where, order, distinct, select, all kinds of joins. Yeah. And you can also work not only with queries, but you can also insert your data into the table without any schemas. You can update it and you can delete it. So you can do all the CRUD operations on the database without defining schemas and do this dynamically if you want to. Another idea is if you want to use change sets, if you want to use schemas and change sets and don't want to use database, and I'll tell you in a bit why would you want to do that, you can do this also. And an example use case is something like a form object where you check the data coming from an external system, but the shape of the data, the schema of the data is completely different from the internal schema of your domain. where you will be saving the data. So you can define those modules, those schemas that define the structure of the external data, validate that, and then pass it inside your system. And if you want to use change sets but don't want to use schemas, you are very welcome to. You just have to pass a map with types of the fields and your initial data, which can be an empty map. And instead of passing the schema to the Ecto change set cast, you can pass just the tuple of the data and the types and use that. Another feature introduced in Acto 2 is concurrent transactional tests. So up until now, when you have the tests, all the tests were running in transaction normally. So at the end of the test, you roll back the transaction and everything works fast. But Acto 2 builds upon that and allows you to have multiple transactions running at the same time with multiple tests. Because in Elixir, you run most of the tests concurrently. If you have 8 cores, you run, well, 8 tests at the same time. But it was not true for the tests that hit the database. But it's fixed now, let's say, and you can run the tests that touch the database concurrently. It only works with Postgres for now, because MySQL has a weird transaction semantics that when you roll back the transactions, it will lock other transactions, and there's a very, very weird edge cases around that. So it also works with Wallaby and Hound, which are 2 integration testing libraries for Elixir. So they use Selenium and render your application in HTML and click around and do stuff like that. You are welcome to use that with transactional tests, which makes those kind of tests that are normally extremely slow just very slow. Yeah. So as I said, Acto does not have models now and does not have callbacks. It had them in the past, but they were both deprecated in Acto 1.1, and now in Acto 2 they are removed. Also, Jose, after my talk at ElixirConf last month, said that I'm not allowed to use the word model when I refer to Acto, so I will not do that. And Phoenix, the Elixir's web framework, will also in future versions switch to this nomenclature, not to talk about models in your application, but rather talk about the schemas, talk about your data, and beside that, talk about behavior you add on top of the data in form of services or whatever you want to call it. But all those changes I showed you, they give you like more power. You can write more code to do exactly the same. Yeah, and sometimes you want that if you want more control. But sometimes you just have a plain CRUD interface. You want to write it and be done with it. And this was very simple in Acto 1. And this is still very simple in Acto 2. There is pretty much no changes into like the default way of doing things. And we don't want to force anything on the users on the library. But at the same time, we want to give you the ability to build simple interfaces quickly and without much code and without much hassle. And here's a quote from Jose that I will read you from the forum. He said that I'm completely okay with taking the blame regarding Acto 1. We did push folks in the wrong direction, but Acto 2 no longer puts you in that place. If you are using structures or domain models, that will be more on you than on me, since you have everything to stop doing that. And this is what reflects the ideas behind Acto 2, is that this is just the database interface. This is not your domain model of your application. And you have to build your domain model yourself because it varies between applications. And you have many tools in Elixir itself to do that. So to sum it up with some couple pompous phrases, Ecto is less opinionated, Ecto is more extensible, it is more data-centric, and it is not the solution to your problem. Rather than that, it is a toolbox that allows you to build your own solution that fits your application. So that was abandoning models and embracing data. Do you have any questions?
Firstly, thanks a lot for your work on the Ecto. We are using Ecto in production into projects now, and that's really appreciated. I have a question about this change sets and verification. You have, for example, this uniqueness check, and it only happens once you hit the database. And I perfectly understand the logic behind it, but it has this nasty, very nasty usability issue that you cannot return all user errors at once.
Yes.
And it's really annoying, and in the end it have to be solved because customers will just demand this better usability of all errors that user made too. So actually I think that this active record approach, even if it's not perfectly clean, because it can happen once in a million that this validation will go through and then the save will still fail, but it was much more pragmatic in terms of real usability. So what's your comment about it?
So if you need that in your application, you can easily build something that will do this, and you can probably look at because we did that in Acto, like I think before 1.0. So you can look at the code that was back then there and like just copy and paste it into your application, and add those validations beside the constraints. So for example, when you just check those at every time you hit the database to check it, and then you have constraints as a fallback mechanism that when this 1 in a million situation happens, when there is someone inserting the data before you, you will catch it as well and return a nice error to the user and not a 500 exception.
Okay, so basically the code is there, just we need to grab it and pack it in. So
yeah.
Okay, thank you. The other question is, you are talking about this parallelizing tests with Acto 2. We tried that, but the problem was that when you are using multiple connection in your, let's say, in your action in a controller, this model breaks because it assigns only one connection per test, and then you need several connections because, for example, it's Elixir, right? So you want to parallelize your database access, and you want, if the action requires you to fetch data from several tables, you should parallelize it to have better UX. So, but then you cannot parallelize the tests.
So you actually can do that because this concurrent connection idea is built on top of the idea of ownership. So a process owns a connection to a database, but it can lend it to other processes. So for example, when you start tasks to load things, when you can tell them you can lend them your connection from the main process, and they will use the same connection to talk to the database. And Acto does this internally because Acto, when you preload the data, Acto 2 will preload the data in parallel by default. If you load more than 2 different associations, it will start task for each association and load them in parallel. And it does that internally by telling all the tasks that, hey, you can use the connection from the parent module, from the parent process.
But isn't that there is only one connection for the test? And
so yes, in tests there will be one connection. Yes, in tests there will be one connection, but without it, you will also like have one connection, because like if you want to have transactional tests, like tests happening in a single transaction, you have to use a single connection anyway, because a transaction cannot span multiple connections.
yeah, so it's probably logically impossible to have both.
Yeah. But you can achieve this, that you have parallel stuff using multiple connections in production, but in the tests you reuse the same connection for all the processes.
I have one more last question. Are those two query syntaxes fully compatible, the macro and the pipeline?
Yes, they are compiled down to exactly the same thing, and when it reaches the adapter only sees one thing. So
why do you promote this macro-based syntax? Because the pipeline syntax is clear, and it's the Elixir syntax. Now the macro syntax is a new language. It's neither SQL nor Elixir, and I always forgot the details. I have always to check it up, and I would really love to see this pipeline syntax to be the default and this macro one to be deprecated or something.
The problem with the pipeline syntax is that it breaks with joins. There are issues when you use joins with the pipeline syntax. It does not work very well, because right now joins are used. For example, if you join two tables, you will get a list of like 3 tables, and they are not named. So it's table 1, table 2, table 3. And you have to know what you joined by the time you reach a particular part of code. And this is something we would like to solve, but we don't have an idea how to do it yet, simply.
Thanks a lot. I'm passing over.
Do you use Elixir in production?
Yes.
Okay, and what is your experience? I mean, do you like it?
So, I rather do. I rather do. No, I think like one of the nicest things I noticed is that we finished like this sprint on the application, like this part of the development, I think a month ago. So we did the final deployment, and we basically forgot about it. I haven't looked once at the application for that month, and it just works. And this is a great feature.
Do you have monitoring for the app?
Yes, we do.
Maybe it doesn't work.
We do. We have both exception monitoring and performance one. So, yeah. I looked at the monitoring, but I did not look at the application itself.
What about libraries and problems, because it is a relatively young language, and what about this stuff?
So there is some lack of libraries, but libraries for like most things you would expect are there already, either from Elixir or from Erlang, because you can use all the Erlang libraries directly in Elixir without any additional costs or anything. And Erlang is there like open source for 20 years. So there is a lot of stuff already built in Erlang. On the other hand, when it comes to libraries in the sense of like HTTP wrappers for different APIs, I noticed that I generally roll them by hand, because I just need like to hit 2 endpoints. And instead of pulling this whole big library that does 200 endpoints to whoever knows what, I just write the code with the HTTP client to query those 2 endpoints, and that's it. And it's very easy to do that. The only exception is AWS, which has horrible API, and without a client, you basically can't use it. yes, there is a really good client for HWS.
Okay, thanks.
Okay, wait a second.
I didn't know. I haven't seen Ecto before, and I don't know. I don't even know Elixir.
Okay.
But I'm wondering how the repo looks like, the interface of the repo, because you have several different adapters, and there are differences between different databases. So how do you handle those things like aggregations in MongoDB or joins in relational databases?
So joins, as we saw, joins are built into the query syntax, and that's basically where you define your query, and then you pass it to the repo, and the adapter translates it to the SQL. With the MongoDB, we decided not to emulate anything. So if you have join in your queries, we will raise an error and tell you, well, you're using MongoDB, you don't have joins, like, go away. Like, think again about what you're doing. So yeah, when it comes to aggregates on Mongo, there is nothing in the Ecto adapter built in, but you can use easily the functions from the driver, which are quite usable and give you a very nice interface.
Okay, and what about transactions in MongoDB where you have no transactions?
So when you try to start the transaction, we do exactly the same that we do with the joins. We tell you, well, sorry, you don't have transactions.
Okay, and my last question is, how would the interface of this validate email function look like? What would it get as an input when you have an error from the
So
database?
this function would get the change set, and the change set has a couple of fields. One field is is called data, that has the struct that you use to start the change set. Another field is called params, that has the raw params you passed in. But the last of the important fields is called changes, and this field holds the information about all the changes you want to do, so that all the changes you extracted from the params, you converted them to proper types, and then you can validate the values on the changes if that is the proper value.
So, for example,
There's also a helper function called validate change. You give it the field name and a function to validate it, and yeah, it does what it needs for you.
So if you have, for example, you violated a unique constraint in a Postgres database, then you have this error message which tells you which constraint was violated.
Yeah.
And where do you get this data? Do you parse the error message or?
So Acto internally parses the error message, but I haven't shown that. But how you interface the change set with repo. So basically you have a repo.insert function, and you or update or delete, and you pass the change set, and you will either get a tuple containing OK and the updated stuff, the updated struct, or error and the change set. And the change set will have a errors field, which will be a list of all the errors that were added to the change set from the validations or from the constraints or from other fields.
Okay, thank you.
Right. One more question from me. Do you guys plan to get rid of the modal naming, not only when talking about it, but also from the code of the Ecto itself and from documentation? Because I recently did git grep modal, on Ecto repo, and it sort of doesn't show that the models are gone.
There was a lot of effort to remove them, but they may still be there. Yeah. If you find them, you can create a pull request to remove them, and we will definitely.
Okay.
It will be merged.
Okay,
Yeah,
cool.
so
Thank you.
I will personally click the merge button.
Thank you.
So yeah.
Okay, so I think that's it. Thank you very much once again.
Thank you.